Good morning. Welcome to Reline Live. This will be the last one we do this year. Oh, I have to record this. Hold on one second. I'm going to start over.
Okay.
Actually, you've got to start it, Don, because this is what we didn't do last time, which is why we're redoing this again.
It shows that, let me just make sure. That little cloud with the red button, that means it's recording, right?
Right.
Yeah, it's doing it.
It is on. Okay. Because yeah, as long as you're showing that it's recording, that's all we need.
Yeah, hopefully it shows
Okay.
up on your end when we're done.
Okay, great. Well, anyway, welcome everyone. Don is going to be presenting a couple of cool projects that he has done over in his neck of the woods with Channel Line. Michael and I are actually working on a couple of projects in our neck of the woods that hopefully by next year we'll be able to do a Reline Live and show you what we got going on here in the Northwest. But for now, Don's got some neat stuff, and then we'll talk about grouting at the end. Thanks, Don, for joining us. I love this. It's always fun getting together with you. We do it about once a month, it seems like.
Yeah, maybe not often enough. We seem to always have some fun projects to talk about, but I want to also thank everyone who's been on previous ones in the past, and please encourage your colleagues to join us next time, because I'm sure we will continue this well into 2023. But as Cassie mentioned, we've been doing some really cool projects, in the Northeast, where I'm located, with glass reinforced plastic, also known as Channel Line. And for those of you, I heard Cassie before we started this presentation today, I heard her talking to a few folks at Idaho about some circular applications with SnapTight and some of the other high density polyethylene applications we use. But really where GRP or Channel Line shines is in the non-circular business, right? So if you have, if you're an infrastructure department that has arch pipes, box culverts, or if you're on the municipal side and you have sewers that are built out of brick, or maybe some other unique feature that you wouldn't typically find in a circular solution for. So non-circular, typically above 3 feet in diameter, is usually where these solutions are going to shine. Purpose of today is really to highlight some really nice projects that I'm sure that you guys can relate to. But please certainly feel free to interject any questions or type them in the chat box and we'll answer them.
Yeah, I'll be managing the chat box while Don is presenting. So if you guys want to pipe in or you want to unmute, just raise your hand and then I'll kind of make a pause in the presentation and I'll unmute you, or you can just type in the Q&A section and I'll get the questions answered.
Awesome. So we'll play a little I Spy here real quick. If you can see what this is. Cassie, any idea what that is? Actually took me a second.
Oh, I see a hard hat. Is that what you're circling?
That's exactly what that is.
Okay. I
So
had to
good
really
job.
get in there.
So the reason for me telling you guys that is most of these pipes, as I'm sure you've experienced, usually fail, most of them anyway, not all of them, from the invert or the bottom of the pipe. This was a multi-plate pipe arch. You can see the bolts here that underneath Interstate 88. If you're familiar with New York State at all, it goes basically from Schenectady, which is a city just west of Albany, all the way down to Binghamton, which is on the south central side of the state. And underneath Interstate 88 was this large, almost 500-foot run of 13 foot by 9 foot, approximately 13-foot span by 9 foot high pipe arch. And I'm going to guess due to salts, road salts, and maybe some other things causing poor soils, this actually had significant ceiling side corrosion, which is a little bit atypical, but that's all right. But I like to show this application because, you know, it's a little different from what you normally see. You can see some of the groundwater coming through the holes in the ceiling as well. So this is really the reason why this got flagged at the DOT level for New York State. So contractor wins the job, and pretty good practice for any liner, really, I find, is if you can get a mandrel or a template, whether it's through the means of mechanical pulling or just physically building one and checking to make sure that a liner is going to fit inside of a hose pipe. That's always prudent practice, right? In my experience, because you don't want to order 500 feet of material and have it not fit. So these guys were clever. They built basically out of really thin plywood, some 2x4s and some 1x3 this three-dimensional template piece that they could pull through that was representative of what the actual liner is going to look like. And they were able to do some things like check clearances between the bolts and the multi-plates and where the liner was going to fall outside of. So it's always wise to leave just a few inches if possible, whenever possible. Not to say that we couldn't make this a little bit bigger in the corner radiuses, radii or whatever, but they left themselves enough room, matched or exceeded the hydraulics, and off they went. So you can see here, interestingly enough, this multi-plate already had a concrete invert in it. And what I've found over the years is that oftentimes, and this did have it, you can kind of see along the line here, where the concrete invert had met the haunch zone of the multi-plate pipe arch. There was also some corrosion in that at that interface as well. So they were able to they already kind of had a nice smooth surface. So they were able to drive this little cat machine in and bring one piece into each other right off the first starting piece. Worth mentioning that with this material, with this particular pipe style, you can do a couple of different methods. You can push them all in place from one zone, true slip lining, right? Where you're pushing just pieces of pipe from one launch area. Or more traditionally, when you have an open-ended culvert, I'm preferential to putting the first piece in its final resting spot and building backwards from there. It just seems to go a lot easier, pushing less weight, one stick versus maybe 20 sticks in place. A lot easier on the installer, in my opinion.
One thing we should talk about, Don, because we've run into this in the past is, and this is one thing that Channel Line really specializes is in those corners, because this particular job looks like it's a pretty straight run. And so they were able to take that big mandrel and push it all the way through. But how do they, with the corners, like let's say we're going around a bend, what's the best way that we mandrel that?
Yeah, so even before, like if you have a pipe that has bends, to Cassie's point, or sweeps or curves, and you're wondering if a liner is going to fit through, it's actually prudent, in my opinion, to, number one, clean the pipe and then do what we call a LiDAR. LiDAR is a little more money than a traditional 2D survey. But I'll give you an example. The city of Brewer, Maine has a pipe that takes 3 S-curve bends around building foundations. It's an old brick sewer, and it was built in the 1800s. So, in talking to the city, they have no idea, they kind of have an idea of where the curves are, but they're not sure how it goes. So to Cassie's point, recommending the LiDAR so that they can get a true point cloud, throw it into CAD, and then we can actually model a liner segment through that CAD. If you were going to go what I would call the cheaper route and not do a LiDAR, you could still do a template, right? And then lobster tail, meaning you're going to bring a lot shorter sections of channel line through that curve. That's one way to accomplish that. So instead of 8-foot nominal lay lengths, which is what these usually are, then you could do a 1-foot panel or even a 2-foot panel, as long as it'll make that curve. Great question, Cassie. Good point. So this is that project fully completed. Worth mentioning that this was actually intended to be a rolled steel product originally, that they were going to have to weld 44 joints, full penetration weld. They would have been in that stream for probably damn near a month and a half, just welding segments in place. Contractor, who is a fantastic contractor, they had this entire liner pipe in about 7 days. So, and then grouted by the end of day 10, let's say. So 2 weeks. And as I always say, lining jobs are typically the prep. It's all about the prep work, getting the pipe clean, getting access roads established, et cetera, et cetera. They did a phenomenal job in getting this pipe in place. Excuse me. All right. Multi-plate seems to be the theme of the day. So here's another one, way upstate New York, almost in Canada, underneath Route 11, I believe it was, town of Malone, New York, another New York State DOT. And what the DOT there is realizing is that they have a lot of these non-circular shapes that are in need of rehab. And they didn't have a really good method for how to fix these culverts up until now. I actually was a little bit confused. It was a dark, kind of gloomy, rainy day when I was up here, and I'm walking down the pipe and I could see a little bit of corrosion, but I didn't understand why there was an emergency there. And then I turned my head to the right and turned my phone flashlight on and could see the giant gashes in the sidewall of the multiplate. So this is actually what they call a vertical ellipse. So an egg, essentially, or a giant oval, right? So taller than it is wide. Rough dimensions were about, the liner, I think, was about 11 foot tall by 9 foot wide. So you can see the access road here, quite a bit of cover. I want to say 18 to 20 feet, maybe a little bit more on top of this multi-plate pipe. And we shipped this actually in 2 pieces, mostly for economics and freight economy. But also because of the size, it just made sense to ship it as 2 pieces versus 1. So basically a clamshell design where there's a top and there's a bottom, and there's a tongue and groove joint, and that tongue and groove joint goes together with a structural adhesive. You can actually, in these photos, you can see the grout ports, these little white bungs here, and those are where the contractor was able to get the sub in there and plug in his grout hoses to ensure that that got grouted uniformly around the entire circumference.
I'm curious, Don, since we have a very wide spread on this call today. I mean, across the country, we've got Idaho, Colorado, all the way to you in New England.
Yep.
How many, just maybe a raise of hands, since I didn't do this as a formal poll, but how many of you guys use tunnel liner plates in your state or see it? Because it's not something, Seth might be able to correct me. We don't see it a lot in Idaho, but I am curious other states across the country.
You talking tunnel liner plate or multi-plate?
Sorry, multi-plate.
Oh, it's everywhere. Multi-plate's been around for decades, in my opinion. John says yes. John's with New York Thruway Authority.
Yeah. Okay.
Yeah.
Bruce. Yeah. Okay. So yeah.
There's probably thousands upon thousands of them in the ground. So yeah, I mean, to me, again, these big non-circular shapes is where we really, really shine. A couple of the things you'll notice, as the title of this slide says, we installed this in the water, in the flowing stream. So bypass was alleviated, which I believe made New York DEC quite happy. We were able to keep the stream flowing for the most part. Mind you, they contended with a couple of rain events. But the other thing you'll notice in this photo, and I think I have a slide here and 2 slides that'll show you up close, but you'll notice there's some baffles just beyond these men in here to create that stream flow for the aquatic life. Yeah, there you go. So there's an up close of the grout port. But these guys, oops, sorry, got ahead on you guys. Hold on. These guys did something pretty cool. They had a winch, a powered winch on both the upstream and the downstream side of the pipe. So they were able to pull the pieces in place and then take the other one out and back out the sled and bring their sled back to the original position so they could bring in the next piece of liner pipe. So quite a unique and helpful installation process. This is, here we go again with the scrolls. So here it is all put together. We usually like to assemble these, at least a few pieces of them at the plant before they get shipped, because we want to be able to make sure that the owner, whether it's a DOT or municipality, and the contractor know that, hey, here's what this thing's supposed to essentially look like when it's all put together. So we often get nice photos sent to us before it gets shipped. You'll notice too about the product that there's a sticker here, and all the pieces have labels on the inside and the outside. So it's essentially like putting a puzzle piece together. You really can't mess it up. Okay.
Another question I've had actually, I think Michael and I just recently had, Don, was the freight, and Channel Line freighting this in, and what that looks like. One particular contractor reached out to us and said, well, what are we going to do with all of the crates after we unload the product?
Yep.
Do you want to answer that, or do you want me to answer that?
The lumber side of things?
Yeah.
It's just pallets. You're talking about the 4x4. So I've had products shipped on 4x4, and I've had products shipped on pallets.
So one of the projects we were looking at was, they were going to bring it in by train. And so they would bring it in, and obviously in big crates, containers.
Right.
So the question was, what does the contractor do with those containers? And the answer that Channel Line has come up with is they will actually wait, have it all unloaded, and then they will take those containers away, so that the contractor's not stuck dealing with that at the end.
No, the containers never. Yeah, in my experience, I agree. They never stay on site.
Yeah.
You're talking about the medical.
It was a good question though, from a contractor standpoint, on, you know, having to trying to figure that out after the fact, once you got the material unloaded. But in that situation, Channel Line handles that.
Gotcha. Yeah, absolutely. Yeah, so you depending on, you know, what shape and size you're looking at a quote from either Cassie or myself, if it's I'm going to call it medium sized, you know, if you have like a 5x6 or something like that, arch pipe, those are usually going to come in one monolithic piece. If you've got something all of a sudden that's 10, 11, 12 feet in either direction, then usually those are going to be a two-piece design, just because of, again, freight economies and things of that nature. It is, I will say it's a relatively quick process. Insert foot and mouth here, but you know, it's relatively quick to put tops and bottoms together. The adhesive dries very, very quick. So in theory, by the time you're done doing a couple of pieces, the next couple of pieces are ready to be put in the hole, or you can prep them all the day before if you want to, however the contractor wants to go about it. Okay. Highly encourage any questions for the Channel Line. And again, I have tons of photos I can share with you guys separately and offline, or Cassie. Just let me know if you want more photos of these projects or other projects. Be happy to share them with you. So for those of you who have been on some of our past webinars, then you know that Cassie and I often talk about low density cellular concrete, which has been around for over a century, but only in the last couple decades has it really become, I'll use the word refined, to the point that it is more commonly used. It is more familiar to engineers, to owners, because of the ease and applications that it can be used in. So I'm not going to bore you with a bunch of words on this slide, but basically what cellular concrete is Portland cement, water, and air. And that air is the manufactured component of Eric's Industries, right? So what you see there is basically like a shaving cream consistency. It gets shipped as a liquid concentrate. You blow air through it using an air compressor, and it's a diluted concentrate. So there's a bunch of water in it, and it turns into what looks like shaving cream. Why do entities use this? There's a number of reasons. And for annular applications, the top two, in my opinion, are alleviating buoyancy, because buoyancy, obviously you don't want a liner pipe to float, because then your invert's all messed up and it messes with flows. But more importantly is buckling a liner. Every liner can buckle. It doesn't matter whether it's HDPE, GRP, steel, you name it. You can collapse a liner, and that equals project failure, right? So 99.99% of the time, Cassie and I are always going to recommend low density cellular concrete. Accurate statement, Cassie?
Yeah, absolutely accurate.
Fantastic.
And when we get the question, can we just slip line it and leave it? Our answer is no. We do not recommend that.
So, Jude has a question. Go ahead. Let's keep it friendly.
You can unmute yourself, Jude.
What's the collapse pressure on the channel line?
So buckling pressure on the channel line is going to be individual, Jude, based off of the wall thickness. And what I didn't state in the presentation on the channel line portion is that every single design is unique to the project. So this is not a off-the-shelf product. So we don't make it on a mandrel. We make it using hand-built forms, just like building a boat hull. So you may have a wall on one project. I had one in Boston that was almost 3 inches thick. And then you may have a wall on another project that's 3/4 of an inch thick. And then those buckling resistances are usually pretty high. I'm talking anywhere from 5 PSI to about 20 PSI, depending on the wall thickness. But I've seen above that and a little bit below it as well. So just ask, like if you're having if you have a design that Cassie's working on for you, just ask her what the buckling resistance pressure is. We actually crank that out for you in like an hour and get it right back to you. So it's going to vary is the short answer to your question. Hope that helped. So to extend upon what Jude asked, the buckling resistance pressure of channel line or GRP is much higher than some of the other products out there, much higher than like a 16 gauge steel, much higher than HDPE even, because we limit our snap type buckling resistance pressures to 2 PSI. So there's means and methods for doing that. And the utilization of cellular concrete is going to greatly alleviate that. What I was talking about earlier with buckling resistance pressures, you know, there's a lot of contractors, because it's inexpensive and whatnot, they want to use flowable fill. Well, flowable fill's got a ton of sand in it. Excuse me. Sand will want to tend to settle out and then cause a hiccup point for your machine or for the flowability of that material. So what happens is it all gets stuck, maybe 40 or 50 feet into your line, creates a pile, and then all of a sudden you've got a potential buckling zone right there. So flowable fill, in my experience anyway, doesn't really go that far. You got to put a lot of energy on it to get to go much more than 50 or 60 feet. Cellular concrete, you can literally pump for hundreds, if not thousands of feet from one entry point. So it helps with the travelability of that material, getting through those little tiny annular spaces that we always talk about for liner projects. So there's Mr. Michael Rothenberg right there showing off his cellular concreting skills. So what you see here, other than his wonderful smile, is basically, and I'll turn this down so everyone doesn't go deaf, but he's holding a pile of foam here.
Yep. There you go.
And what you're going to notice about that pile of foam, if you were to zoom in on that, and you can see it in other photos as well, is each and every air bubble, which sounds funny to talk about air bubbles, but each and every one of them is uniform, right? So it's a very consistent material, which is important. You don't want a foaming concentrate that's sitting in your hand and it looks like Dawn dish detergent bubbles. Big, small, medium, large bubbles, right? You want uniformity in that mix. So what Michael's doing here is he's actually, whoop, sorry. Here we go. I wanted that. So what he's doing is he's blowing the foam. Again, it's going through an air compressor, and there's a nozzle at the end of that, average 20 cubic feet per minute. And that nozzle is injecting that foam that's in his hand on the left into the back of the ready mix truck, or the front, depending on how you look at it. And that's blending with the Portland and water slurry. Out of that chute is going to come the finished product of cellular concrete. I'm not going to go too deep into this just because of lack of time, but the reason, one of the things that has happened in the last couple of decades is the air bubble has gotten a lot stronger. Sounds kind of funny, again, talk about it, but the reason we can pump this stuff hundreds and thousands of feet and still get the same quality at the end of the line as we did at the forefront of the line is because the compressibility of that air bubble is a lot more stable. So it's not going to collapse the bubble. Inherently, what happens when you collapse an air bubble in cellular concrete is you're losing the air. So your mix gets more dense, right? So instead of, let's say you were targeting a 30 pound per cubic foot density, you know, if you collapse an air bubble, you may be up to 50 or 60 pounds per cubic foot at the end of that line. But the strength of the air bubble is very strong these days, as proven. One of the things that Cassie's company, as well as mine, does is we link you guys, engineers and owners, together with written specifications that have already existed in the industry. So you're not starting from scratch on trying to write a spec around cellular concrete. The standards already exist, written industry standards, ASTM C869, 796 and 495. Believe it or not, in my opinion, one of the simplest ones that always gets messed up is the actual testing of that cellular concrete. It's just a weight. It's just having a scale and a known volume at the site so you can weigh it on site, because that weight ultimately leads, it's a very linear relationship between weight and compressive strength, right? So if you have a target of, let's say, 100 PSI, then I know without even looking at a chart that you need about 30 PCF to hit that 100 PSI. And that's what this is telling you. That's what that test does for you. Here's the chart, right? And this is more like a plug and play for engineers and owners, right? Okay, I'm designing my job. Because this has the term concrete in it, people automatically associate, in my experience, 4,000, 5,000 PSI compressive strengths with it. But remember, folks, we're using cellular concrete as a soil replacement. It's a dirt replacement. So very low compressive strengths is 100% acceptable per many of the DOTs in the country for this fill material, for this geotechnical material. Whoop, here we go again. Cassie, I got to stop using my scroll thing. Just so used to it. All right, so courtesy of Snap Tight's design guide, many of you folks have seen this, and this has held true through my years. As long as I follow this chart, I usually don't get myself in any trouble. But what I like to show this for is really a flow fill. I won't use it if it's any more than 55, 60 feet-ish. I kind of push it sometimes, and it's very seldom that I do. And then cellular grout, you see, has the check boxes on all the linear feet. So if you go cellular grout greater than 125 feet, it's going to, and notice all the boxes are checked here for all the footages. Here's an extreme condition. Okay, so this one is in Washington State. Was not one of my projects, but I like to show it because it's kind of like a extreme project just to show you the capabilities of the material. 14,000 feet long. Okay, so for the mathematicians on the call, that's just about 3 miles, 260 feet below the surface, 70,000 cubic yards of annulus. So that's the space behind this bulkhead in between all 4 of these pipes at 500 PSI. There's really no other material you can do this job with, in my opinion. Keeping pressures down, what we talked about earlier, is also important. And this is typically our culvert scenario right here, whereas you have a liner, you have a host, and you have an annulus that you got to fill. The other important thing is when you have voids behind a host pipe where your subsidences in the road are caused by washouts inside this pipe, that grout is going to fill not just the annulus, but also the voids outside of that host pipe wall. Okay. So this is actually, yet again, another New York State DOT project. This is Interstate 86 down near pretty much western, almost into Cattaraugus County, this project. So this is about a 6 by 7.5 pipe arch, about 400 feet of that. And you can see that went in very, very slick.
That was just last week, Don?
Nah. That was, so this would have been commentary from our last.
Oh, so it was in November.
Yeah, this was November.
Okay. Do we have any other questions? I don't see anyone typing anything in the Q&A box. So this was awesome. This will be, it is being recorded. We will have it on our YouTube channel within 24 hours. If anyone needs a certificate from me, just shoot me an email. Don and I are happy to offer the PDH credits if they're available in your state, if you guys need them. Otherwise, let us know what we can do to help.
I'll leave it open for another 2 minutes just in case anyone wants to ask a question.
Absolutely.
Everyone has the ability to speak if they want to unmute themselves. Okay, everyone. Well, happy holidays, and thanks again. Cassie, thank you so much for inviting me as always. I appreciate it.
We will be back in 2023 with more Reline Lives, you guys. Let us know what topics you want to hear about.
Thanks, Cassie. Thanks, Don.
Yeah, thank you guys. Have a great holiday.
You too.